So this is 2.2 part 2. So our graphs of quadratic functions either have a maximum or minimum. If it opens up, like this one on the left, then our vertex is at the lowest point, so that would make it a minimum. If it opens down, then our vertex is at the highest point, so that would make it a maximum. When we find our vertex, it's always h comma k. The minimum value is the k part. So whatever that k, the y coordinate in our point, that's the minimum value. So when we have h comma k, either the maximum or the minimum is always the k. So it's just the k. So only the k. Now we're going to be asked to find the domain and range. The domain is always all real numbers. So whether it opens up or down, it's all real numbers. So you can say all real numbers. You can say ARN, or you can say this symbol, so like an R but with 2 bars. Both of these mean all real numbers. So domain, always all real numbers. The range, when it opens up, we always start at the smallest value. So it would start at the minimum, which would be our k value, and it goes to infinity. So we would write it like this, with a bracket at k and a parentheses at infinity, because k is included there. And then if it opens down, our arrows go down to negative infinity, so it would be negative infinity to k. So it just depends on which way it opens for the range.
So we don't have to do that.
And then you don't have to worry about decreasing or increasing. So all we're going to be finding here is the max or min and the domain and range. All right, so for example 3, it says find the minimum value or maximum value of our graph and describe the domain and range of the function and where the function is increasing and decreasing. So we just have to find the domain and range. Don't worry about increasing or decreasing. So to find my max or min, it's either going to open up or down. How do I know just by looking at my equation which way this graph opens?
It's going to open up by looking at the first number because it's positive.
We always look at our a, and when a is positive, we know our graph opens up. So is my vertex going to be at the maximum or minimum?
Minimum.
The minimum. So I have a minimum. Now my minimum is my k value. So I have to figure out what my vertex is before I can actually find my minimum value. How can I find the vertex? We use negative b over 2a to find our h, and then we plug it in to find the k.
And H is the, like, what is that?
H is the first number in our vertex, and then k is the second. So the k is what gets repeated in the minimum. We're just going to find everything here, so I'm going to rewrite it all here. So we're going to find our vertex, the axis of symmetry, the max or min, but we said it was a minimum, and we need to find the domain and range. So when you see questions like these on the quiz, it'll ask for everything like this, and it'll say graph. So we found the vertex and axis of symmetry in the first part. Now we're going to find the last 3 things. So to find our vertex, we need our little formula, negative b over 2a. What's my a? 1/2. And what's b?
2.
Negative 2. So it would be negative 2 over 2 times 1/2. So that becomes positive 2. What's 2 times 1/2? 1. and 2 over 1 is just 2. So my h in my vertex, the first number in my vertex is 2. How do I find the k? Plug it in. So I have 1/2 times 2 squared minus 2 times 2 minus 1. So we plug it into all of our x's in the original equation. And then we solve. What do I have to do first to solve here? Square the 2. So I do the exponent first. So 2 squared would be 4. So 1/2 times 4 minus 4 minus 1. What's 1/2 times 4? 2. So 2 minus 4 minus 1. 2 minus 4 would be -2, and -2 minus 1 would be -3. Bless you. So the second number in my vertex is -3. What is my axis of symmetry? It's 2. X is equal to 2. It's always the h, the first number. Is that what you said?
Yeah.
Oh, I thought you said 3. I'm sorry. So axis of symmetry is x is equal to 2. What's my minimum? Remember, minimum is the k. So -3. So the h gets repeated in the axis of symmetry, but the k gets repeated in the minimum. What's my domain? Go back to the last page. What did it say the domain always is? All real numbers. So we can say ARN for all real numbers.
So no matter what, just do real numbers?
Always. It's like a freebie question. It'll always be all real numbers. Just got to remember it. And then lastly, let's find the range. So our range is y values. What's my smallest y value on my graph here? So looking at this, where does my graph start? -3. And then it goes up to what? To infinity. So that k gets repeated again in the range. So your h gets repeated in the vertex and the axis of symmetry. The k comes from the vertex. It gets repeated in the minimum and the range. All right, let's do one more. We're going to do A, so you can cross out B so we don't get confused. We're going to find the minimum or maximum value of A and describe the domain and range. So just like before, we're going to find everything. So we need the vertex, the axis of symmetry, the max or min, and the domain and range. So looking at my graph, do I know it's going to open up or down? It opens up. How did we know that? Because A is positive. So when your A is positive, we know it opens up. It'll be a smiley face. So is my vertex at the maximum or minimum? It's at the minimum. It's at the smallest part of our graph. Now let's figure out what our vertex is. How do I find my vertex? -b over 2a. So my b is 16, so it'd be -16 over 2, and a is 4, so over 2 times 4. So this would be -16 over 8, and what does that simplify to? -2. So my vertex, the first number is -2. So what does that mean my axis of symmetry is? Just -2? X equals -2. That is h. How do I find the second number in my vertex? Plug it in. So we plug it into all of our x's in the original equation. So this would be 4 times -2 squared plus 16 times -2 minus 3. Just be careful when you plug it in that you are following your order of operations. So first I have to square negative 2. So that would be 4. So you're at 4 times 4. Plus 16 times negative 2 would be negative 32 minus 3. 4 times 4 is 16. So 16 minus 32 minus 3. We get negative 16 minus 3, which is negative 19. So the second number in my vertex is negative 19. So what's my minimum value?
Negative 19.
Yes. What's my domain? All real numbers. And then what's my range?
Negative 19, comma, 19.
Perfect. Negative 19, because that's the smallest y value on my graph. And then my graph goes up to infinity, so negative 19 to infinity. Any other questions here? All right. Next, we're going to look at graphing quadratic functions using the x-intercepts. So when we use the x-intercepts, it's going to be written for us in intercept form, which is with the parentheses here. So it's going to pretty much already be factored for us. And we know that when it's factored, we could set both of these parentheses equal to 0 to find our solutions. So that's pretty much what we would do here. And then to find the axis of symmetry, we just add those two numbers. So we add P and Q and divide by 2. So this is how we find the axis of symmetry. So here we have to label the x-intercepts, the vertex, and the axis of symmetry. Oh, and we have to graph. So looking at our graph here, I would set both of these equal to 0. So I have x plus 3 equals 0 and x minus 1 equals 0. So x is equal to negative 3 and x is equal to positive 1. So on my graph, I'm going to put a point on the x-axis at negative 3 and 1. So those are my x-intercepts. Yeah, the 2 is our A. We just ignore it. It doesn't really, do anything. But it does tell us if our A is negative, do we know which direction our graph is going to open? It'll open down. So that's what the A tells us. So these are x-intercepts. Next, we can find our vertex and the axis of symmetry. So it gives us a formula for our axis of symmetry. We add the two x-intercepts together and divide by 2. We're pretty much finding where our vertex falls in between these 2 points. So we add them together and divide by 2. So this will be negative 3 plus 1 divided by 2. So negative 2 over 2, which would be negative 1. So my axis of symmetry is x is equal to negative 1. So I put my dotted line right through negative 1. So what does that mean the first number in my vertex is? Negative 1, the same thing. How do I find the second number? Plug it in. Same way we found it before. We plug it into our equation. So that would be negative 2 times negative 1 plus 3 times negative 1 minus 1. So then we just solve. So I have negative 2 times 2 times negative 2. So here we're multiplying all three of these things together. So it's negative 2 times negative 2. Negative 2 times 2 would be negative 4. And then negative 4 times negative 2 would be positive 8. So the second number of my vertex is positive 8. So I can graph that point. I stay to the left negative 1 and go up 8. And then I have my 3 points on my parabola, so I can just graph it. So when it has the 2 sets of parentheses, that's when it's in intercept form, so you just have to find the x-intercepts. And then you can find the vertex and axis of symmetry. Let's look at number 6. So we have to graph, label the x-intercepts, the vertex, and the axis of symmetry. So it's in intercept form, so how can I find my x-intercepts? Set them equal to 0. So x plus 1 is equal to 0, and x plus 5 is equal to 0. So x is equal to negative 1 and negative 5. So those are my x-intercepts. So on my graph, I can plot my points at negative 1 and negative 5. What do we want to find next? The axis of symmetry. How do I find the axis of symmetry? Add the 2 intercepts together and divide by 2. So what's negative 1 plus negative 5? Negative 6. And negative 6 divided by 2? Negative 3. So my axis of symmetry is x is equal to negative 3. So I can put a dotted line right through negative 3. It'll always be right in between your x-intercepts. It'll be the center of them. If you did the math here and got a line over here that has nothing to do with your 2 x-intercepts, then you did something wrong with the math. It'll always be right in between them. So what does that mean the first number in my vertex is going to be? Negative 3. How do I find the second number? Plug in negative 3 into my x's in the original equation. So I have negative 3 plus 1 times negative 3 plus 5. So negative 2 times positive 2. So negative times negative 2 would be positive 2 times positive 2, which is 4. So the second number in my vertex is 4. So then I can graph my vertex. I'm going to go up 4 and put a point. And then I can draw my parabola. All right, so number 7, what should I do first? Perfect. I set my parentheses equal to 0. So x minus 6 is equal to 0, and x minus 2 is equal to 0. So what does x equal? 6 and 2. So those are my x-intercepts. So I'm going to graph those 2 points. Go to the right 2, positive 2, and positive 6. What can I find next? The axis of symmetry. How do I find my axis of symmetry? Perfect. I add my 2 x-intercepts and divide by 2. So 6 plus 2 divided by 2 would be 8 over 2, which is 4. So my axis of symmetry is x is equal to 4. So I'm going to put a dotted line right through 4. Now how do I find my vertex? Perfect. The first number of my vertex is 4, and then to find the second number, we plug it into our equation that we started with. So this would be 1/4 times 4 minus 6 times 4 minus 2. So 1/4 times -2 times 2. I'm going to multiply the two whole numbers first. So -2 times 2 would be -4. And what's -4 times 1/4? -1. So the second number in my vertex is -1. So I'm going to plot that point. I'm going to go to the right 4 and down to -1. Once we have our 3 points, we can graph our parabola. So this is going to be a wide parabola.